Benvenuti, good morning, ladies and gentlemen, and a very warm welcome to the Slab Track Forum 2025 here in beautiful Naples. As the president of the UEEIV, it's my great pleasure to open this year's main conference, and I'm a freelance railway systems engineer and appraiser for O&M, track work and rolling stock, and I'm dealing with heavy rail, light rail and tramways, and therefore I know the power of slab tracks. We have chosen Naples not only for its excellent food and for the pleasant November climate conditions, but also because of our close friendship and collaboration with our Italian colleagues from CIFI, and because of Naples is a truly railway city. Here, many different types of railway infrastructure have already been implemented using slab track technology, from the metro and light rail system to the harbor connections, and maybe in some railway lines. Naples offers a perfect living laboratory to see, discuss, and understand how slab track performs real-world conditions. Over the next 2 days, we will have the opportunity to exchange ideas, share best practice, and explore the latest innovations in slab track systems, both from a technical and operational point of view. We have a lot of sponsors. They have their booths outside there, and without them it is not possible to organize such a conference, so thank you very much to our sponsors. And I can recommend you to go to visit the sponsor booths, to look at the products and to discuss with the experts. Yeah, I will not use so much time, so I think we should urgently start. Thank you very much, and I wish you an inspiring and enjoyable conference. So now we will start with our colleague Gianpiero Strisciuglio. He's the president of CIFI, but he could not come to here, so he's online, and we will hear his words now.
Good morning, everyone. Good morning.
Yeah, hello, we can hear you, but we don't see you.
Yes. There is no video?
Yeah, 1 second. Are you preparing the Teams? Okay, perfect. Now we see you and we can hear you. Please go ahead.
Thank you. Thank you.
Thank you.
Good morning, everyone. It's a real pleasure to send you my warmest greetings, even if I can't be with you this morning. A greeting as a president of CIFI and CEO of Trenitalia. The Railway Forum 2025, promoted by the Union of European Railway Engineer Association together with CIFI, is a major international event, and this year it focuses on slab track, a technology that's changing the way we think about and build railway infrastructure. Slab track offers durability, lower maintenance and high performance, especially for high-speed lines and urban transportation systems. It's not just a technical solution, it's a strategic choice. The partnership between CIFI and the Union of European Railway Engineer Associations plays a role in this journey. It brings together knowledge, experience and a European perspective, creating a space for open dialogue that drives innovation and strengthens our engineering culture. It's a great example of international cooperation, and as CIFI, we are proud to be a part of this. Innovation in rail, it also comes from our ability to combine new technologies with a broader forward-looking vision of mobility. Thank you for the commitment. I wish you a productive and inspiring couple of days in the beautiful setting of Pietrarsa Railway Museum, a place where a piece of Italy's railway history was written and where the legacy of the Italian State Railways lives on, celebrating its 120th anniversary this year. Thank you and have a good day.
Thank you, Gianpiero. And now we have the greeting words from Orvitti Oreste. He is the General Director of Fondazione FS.
Buongiorno, benvenuti.
Good morning and welcome to the National Railway Museum in Pietrarsa. In the name of the Foundation Ferrovie dello Stato and engineer Luigi Cantamessa, General Director, I would like to convey my greetings and for this conference within the museum. The National Railway Museum of Pietrarsa is our history, our legacy. Every single brick, every item exhibited here, displayed here, tells us a story about the history of Italian railways over 180 years. Our symbol, Ferrovie dello Stato, you can see here, recalls this history. It's a reason to be proud here in Italy for this museum. We want to actually, the fact of being able to host such an important meeting as today's is a reason to be proud. We are proud and very happy to be able to accommodate you. We would like to thank the organizers and CIFI for this important moment of sharing. We would like to wish you a fruitful activity during this two-day journey in this beautiful setting. Thank you.
Yeah, thank you, Orvitti. So now it's real time to start, and my president colleague from the UEEIV, Bernhard Knoll, is the moderator of the first session. So Bernhard, take over. Thank you.
Thank you. Yeah, very warm welcome also from my side. My name is Bernhard Knoll. I'm the Vice President of the UEEIV, and I have the pleasure to be the moderator of the first session in this morning. I would kindly ask our first speakers to come to the podium. It is Mr. Vlad Metaxa from PORR GmbH from Austria. He's a slab track engineering specialist, and he will give us a presentation together with Mr. Rudolf Felsner, who is an expert from VCE, Austrian engineering company. He did some major projects all over the world, and they will give us a very interesting speech, which is named Highly Versatile and Proven Slab Track Technology for a Range of Demanding Railway Applications. So a very long title, and I'm really interested what is behind this title. So I would kindly ask all the speakers to look on the timetable that we do not run out of time. There is a timer running very critically down. So I will show you the yellow card and at least, hopefully not the red card, if it is too long. So please feel free to start and we will enjoy your presentation.
Thank you very much, Mr. Knoll. Thank you everyone for coming to this event. It's great to see and have all the slab track technology, European, at least at one place, and to share experience. What we will do today and what is behind our presentation, it's actually we want to present the lesson learned from all international projects we did and delivered. So once again, my name is Vlad Metaxa from PORR. I'm the engineering lead of our Slab Track International Division. And together with me, we have Rudi Felsner from VCE, which is our design part. And together, we will share experiences from the contractor's point of view and delivery point of view, and of course, the design part, which is a very critical and important part of the slab track.
So, thank you very much. Also from my side, a warm welcome. Our talk today combines both perspectives, the perspective from the construction side by Vlad and the perspective of my side from the design. And we will move quickly through the slides. It's a broad topic, and we want to keep it pretty practical. So let's start with a general information about the slab track Austria. Every successful story starts with a beginning, and our beginning was in 1989 with the first installation of slab track Austria, a precast slab track system by the Austrian Federal Railway, here better known as ÖBB, and it quickly becomes a standard practice in Austria, and now over more than 35 years later it has carried 1.5 billion cross tons. For me, it's a solid proof of its durability. And from my point of view, the key benefits are the lightweight design, the easy to installation, the easy maintenance, and the long life, and then that translates to less life cycle costs and also excellent ride comfort for all of us. So Vlad, from your side?
Yeah, from the constructability and contractor point of view, the slab track, we like it and we like to apply it because it's a prefabricated, has a high degree of prefabrication, and that means you can do a lot of activity off-site, so you don't need to focus only on the civil works that sometimes they get delayed and so on. So you can prefabricate all the elements in advance to a very high accuracy, a very high quality, and in a controlled environment, and then they can be delivered on site when the access is there, and you can achieve a very high accuracy, very high tolerances for installation, and that gives a very fast installation speed. So yeah, now we will go a little bit into the components of the system. Again, it's a prefabricated modular panel, the PORR slab track or slab track Austria. It's a prefabricated element. It has two grouting openings that are used to cast the self-compacting concrete and introduce it under the slab, which is very good because you can compensate for the tolerances of the substructures if they are not okay, if they are not even. Then we have the spindle holes, which we have 4 to 5 on each slab, depending on the type or the length of the slab and the weight. And then we have the separation layer, which is actually the main feature of the system, which allows for replacement if needed during maintenance and operation times. So this is one of the highlights. I think that ÖBB came into when the system was created, and that was one of the required to maintain the debonding between the self-compacting concrete that is cast in situ, so the monolith component from the prefabricated element, in order to be able to replace this slab. And then we have the self-compacting concrete, which is a standard normal concrete, of course with a different flow slump. And then in terms of adaptability, and we'll go in details through all the projects, we'll show that the derailment containment can be embedded in the system, which of course reduces the cost overall, so during production. From the applicability point of view?
Yeah, as a designer, I brought some plans with me. It's just to sum up that slab track Austria fits to any structure of it. If it's a tunnel, it's a bridge or a grade section. We just need small adjustments to detailing, and the same fundamental layout simplifies the design coordination across the contracts and also reduce the interface risks. And no project is like the other project, so that is also modular equipment to be placed on the slab track Austria, such as integrated manholes or noise protection or a third-rate guardrail and many more. And of course, the system is also available for turnouts to realize switches and crossings.
Yeah, beside the turnouts, we had also the installation of the rail expansion device, which is also a very critical component on long bridges that require such, let's say, complex systems. And this was already implemented, and it is under operation since 1.5 years now, and we have successful results out of it. Now we will go a little bit more practical, finish with that was just an introduction to let you know what we are talking about, yeah? But we will go into the project. So I think this is more or less what everybody's here for. And what were the challenges? For example, we start with HS2 project. What was the main challenge of the project was the high speed, operational speed and design speed, which was premier in Europe. It's the first time when an authority is requesting directly to design the track for 400 kilometers per hour and to have an operational speed of 360 kilometers per hour. Of course, the benefit and the good thing that that was the challenge. Now, the good thing that we faced on this project was that the project was awarded the track component. Instead of waiting years after the civil contractors are completed, the track package was awarded in the beginning. So what that means, it helped for the interface integration with the track and to design and optimize the structures for this type of track, knowing directly what type of track it's provided. So this contract for us, it's a design and supply. We will not do the installation. We'll just provide supervision for installation and training. However, we will supply and maintain and be sure that the quality of the produced element is there in accordance with our specifications and the client specifications. And of course, also the installation will be in accordance with that. From the design point of view?
So from design point of view, for us was the main part the design optimization, or let's say the clearance, because every millimeter counts at 360. And also the interface management to get fit for purpose, the civil works, leads to a slim geometry. That also counts in the weight and material reduction. Because of the lower self-weight, this helps structures to slim, to help that they have much less self-weight on it. And so it's easier for the structures and for the logistics. And also for us, the information modeling was here focused on the asset information modeling and not on the BIM modeling. So it's very important to get the right information at the right time to the right phase of the project and not to get too much to the models.
Yeah, so now going forward, the project commencement of production is on the way. So we did not start yet the production, but we still have a lot of coordination with the awarded track installer, and already we have a lot of dialogue in terms of implementation of the system. So the key point for this project for us, it's the high precision of the accuracy of the prefabricated elements and the coordination and interfacing, early interfacing with the part that will deliver the project.
So let's change the country. Let's change to Germany, another high-speed track we built. This was a very interesting reference because this is it's a upgraded and a new built line between Berlin and Munich, and it's in operation with 300 kilometers operation speed, with a total length of 188 kilometers in double track with 25 tunnels, 32 bridges, and also more of the over 50% on earthworks, and we are very proud that we are, it's now full operated since December 2015, and we are very proud that we built it in time.
Yeah, from our perspective, it was a design, supply, and build, so we had the full package of the project. And what it's important to mention, and we are proud of, was that the Deutsche Bahn tested the new generation of trains of Siemens with on the area that was designed for 330 kilometers per hour, and they reached the speed record of 405 kilometers per hour. Of course, for Europe, it's a premiere, and what we want to highlight actually the fact that the accuracy of the track. So they didn't have to do anything on the track for this special test. The accuracy of the track and the quality of the track was the same as we left it 10 years ago after 10 years of operation. So this is, for us, what shows properly that a quality, well-installed track in the beginning will last and will decrease the maintenance cost, what our colleagues from the authority was mentioning a little bit earlier.
So let's switch to Austria, another country, my home base. Here the space constraints at the core arm tunnel was the biggest challenges we had to deal with because of the small tunnel diameter and its length from 33 kilometer in twin bonds, and also the strict limitations to noise and vibration. And also special for the design was the manholes in the, for the drainage in the middle of the track.
Yeah, the solution that we came for this project was to reduce the width. Normally our slab is 2.4 meter, but for this project we reduced the width to 2.12 meter. And another aspect, and what we are facing from contracting point of view, is that the tunnels are longer and longer, yeah? And we need to cope with that with the installation, because you still need to deliver in time, but you are limited in access points. So therefore, our colleagues from Deutsche Bank, from Bahnbau came with a clever idea, together with ÖBB, to install the sections, the tunnel, even not having full access from both ends of the tunnel. So this was a premiere for us, and it was very, very successfully implemented. Going forward, some details of the...
From the design side, we deal with the width of the system, because we had some higher tolerances to compare, and there we had to reduce the clearance, and we made it with integration from the mass spring throat to a mass spring slab system. And so we can reduce it to 70 centimeters, but we also want to reduce the alignment changes over the whole project. So we also reduces here now the system width from the whole system up to 71 centimeters. And this is overall a reduction by 25% of the system width. The same is with the system height. We also tried to make some improvements, because on the one side we made the system height to nearly 50 centimeters. This has disadvantages. There is also the less alignment changes needed in the vertical way, and also no special tunnel shapes are needed anymore, because tunnel shapes, in fact, directly, especially by as long project as the core arm tunnel is, that we need bigger diameters and also need more construction time for it, and so we don't need this special tunnel shapes because of the height. And the most impressive for me was the flexible noise and vibration adjustment, because now we had a very low system height. It was now possible to allow that the noise and vibration protection measurement to be adjusted until just before the track is installed. So it was a very good thing that exact area definition weren't needed during the tunnel construction, where we had now a system that can put everywhere, and at the core arm tunnel it was even there that the mass spring systems are now placed in some areas which the original design was was only designed for fixed tracks.
Yeah. So we
just
move
from flexible to flexible.
Yeah.
I will
so
go on.
We move
Sorry.
on a little bit, being aware of timing. We will go now on other continents. So as you go further away from Europe, you find and face different challenges. One of it in Melbourne, in Australia, we delivered the track for CYP, Cross-Sierra Partnership, and there we had to do the slab adapted to 1.6 rail gauge, so broad gauge. And we designed the slabs in such a way still to be transportable in a container, so they were thin, not 2.4, they were having a reduced width. They were produced with integrated derailment containment. We addressed complex noise and vibration requirements as floating slab track, high attenuation track, so we had different fastening system within the slabs. And yeah, we moved to next project that it's India, the NCRTC. There are people around here that they know about this project. It's a landmark project for us as well, because here we did only the system design and the supervision for installation, and that was a contract with the authority, and then it was implemented by local contractors, so the in-country value was kept in India. And one of the complex and challenging project we delivered was Doha Metro in Qatar, which was complex from the very multiple perspectives, if you look at it. However, one of the most challenging point was that we had to coordinate with 7 different civil contractors, which were constructing in the same time the tunnels and the stations and the elevated sections, and to integrate the whole track together in the same time and deliver in time. So that was the challenge of the project and the tasks we had to cope with there.
So just want to point out this beam was from the first day, and this was also, for our experience, we started with parking riverside to use Paintly instead of Autodesk, and we also made it in Australia, but in fact of time we go to the next project.
Yes, yes. So the next project, it's the Stuttgart 21, which was just completed by our colleagues from Bahnbau. We are talking about 33 kilometers of tunnel, slab track installed in tunnel. The key point that we want to highlight in this project was that the slab track was installed without the rail. Usually, PORR slab track, it's installed as a top-down methodology, starting from the top of rail, going down and compensate whatever is underneath. However, in this part of the contract, we did not have the rail to do the installation, but we found solutions to do the survey and maintain the accuracy of the track and deliver in time.
So from the design point of view, we had some design approaches, and we made a lesson learned of known asphalt layer-based systems. So we made a modification of the asphalt mix for longer durability and also for a lower impact to the environment. Also, the asphalt layer was fully covered. It's not that important in the tunnel, but as you see, remember the picture before, it was also outside from the sun. But the main interesting thing maybe for you is that the asphalt layer can be made without strict tolerances. So it's not to be necessary to make more work steps on it to get a smooth surface, because our self-compacting concrete will compensate this difference of tolerances. And also, therefore, we don't need any connections between them. We don't need shear towels or something else to connect them.
Yeah. So it's a good bonding between the asphalt and the self-compacting concrete in the system. Now going to the overall, so yeah, as we said, it's very important to say that since 4 decades this system is used and has a proven technology, and therefore we can stand for the future, for the new challenges and new requirements that we will have, and of course all this due to the fact that we are talking about a prefabricated modular panel.
So from my side, by looking on the clock, it's the most benefits system is this is a modular system. This is high precision made, and it is really proven over decades. And I would say we are ready to face new challenges. And
so as a closure, and with that we'll finish, so we are almost there, Mr. that the main key words are precision, performance, and partnerships. So we will find ways to work with the clients, find ways to work with the authorities, and deliver what is needed.
Yeah. And I'm proud to make the closing. For me, when I look back from my personal decades of designing slab track Austria, for me stands precision and partnership made key ingredients for a successful slab track project, and that's exactly what slab track Austria delivers.
Thank you very much. We still have 11 seconds.
Perfect. Thank you very much for your presentation. We will keep if you have any questions, we will keep it in a special question and answer session afterwards. We will do our 3 presentations now in a row, and then you have the opportunity to give some questions to one of the 3 speakers. If someone of you needs a translation from Italian to German to English or backwards, please feel free to take your headset with you if you haven't done it so far. So thank you for the first very interesting speech, and we will proceed to Mr. Giulio Maria Besemer, who is the Development and Innovation Manager from Salcef Group here in Italy, and he will give us a presentation on fast system innovations in ballastless tracks. So happy to have you here.
Thank you for the presentation, and I'm happy to be here today and speak in front of you. So I'm Giulia Besemer, working for Salcef Group, and in the next 20 minutes I will keep the time. I will talk to you about renewal works and renewal works with respect to slab track systems. So I would start with a kind of easy question. What's the main issue in track work? So when we're talking about renewal works, we are mainly facing two constraints that are also our biggest resources, that are time and track possessions, so time in which we can do our work. And these two factors actually have a direct link, a negative link on operations, because due to track works, we have possible cancellations, delays, disappointment among people and infrastructure managers. And all these factors actually are even more enhanced when we're talking about slab track, because slab track construction is way different than ballasted track construction. It needs more time. The materials need more time to gain their strength. We're using cementitious materials normally, concrete, which needs time to gain its mechanical strength in order to withstand the train traffic loads. So a complete new challenge came to our minds in Salcef, and we started to think, is it possible to go from a ballasted track to a ballastless track working just overnight, and then resuming the train traffic the day after? And so we scratched together actually our years of experience in track work and our capabilities in design, in innovation, and in the precast production of our facilities and machinery. And we came up with a solution to this topic. And so our fast slab track system came to birth, and I'm happy to show you today how it is working. And what I want to stress is that it's not just a slab track system, but actually it's a renewing track solution. So what's it all about? We're talking about a precast slab that is put in place with a concrete filling layer. You can see our slab here on the screen. It's a slab among many slabs, roughly 5 meters long, 2.4 meters wide, 22 centimeters thick. We have 8 pairs of rail seats and gauge that goes from normal to reduced or metric. Our slab indeed is particular in some ways. So we have a reinforcement that is normal reinforcement, but also pretensions reinforcement. So our slab is pretensioned in 2 directions, in the longitudinal direction and in transversal direction. Also, we have 2 key elements that are the mechanical support system, with which our slabs are equipped, and the possibility to produce the slabs with a variable geometry system. But let's go a bit deeper into these 2 topics. The mechanical support system is actually the heart of our system. It is composed of the spindles that you can see in the picture on the left. The spindles are applied on the underpart of our slab and are composed of 2 elements, a screw and a base plate. And our support system fulfills mainly 3 functions. So the first function is for sure the most important, because it gains our temporary support during the installation phase. Every slab rests on 14 spindles, and so in this temporary configuration, it is possible to resume train traffic just standing on these mechanical supports. Second, acting on these spindles and on the screws, it is possible to adjust the vertical alignment of the slab, and so to reach the design alignment. Third, it enables maintainability of our slab track system. reinserting the screws in the slabs in a future time, it enables us to lift the slab and to replace it with a new slab. This is, for instance, necessary when a slab gets damaged. So, but just this is not everything. So the second key feature of our slab is the variable geometry system. With this system, it is possible using this kind of special mold, which is patent, to produce customized slabs. This means that the single rail seats can be moved and put in the correct position by rotation and displacement, and so to adjust to the track alignment. This obviously brings advantages. We have a better distribution of the tensions inside the slabs, stress peaks are reduced, and so also the risk of damages in the rail seat area. Secondly, we have also the advantage that we do not need to rely on the regulation possibilities of our fastening systems. So this regulation remains fully available for the infrastructure managers in order to do maintenance if needed in future. But the configuration of our system is not enough to do the trick. So I was talking about a complete system, and as everything that needs to be built, we need three main components. So we need the materials, we need the technique, and we need the correct tools, just like a furniture piece of IKEA. And so in our case, obviously, the material is the slab with its features. The technique is our construction method, and the tools are given by our work trains. The construction method can be summarized roughly into 4 phases. We have the dismantling of the existing ballasted track, the positioning of our slabs on the underground, the installation and the final check of the new rails, and the grouting of the concrete filling layer that is fixing the position of the slabs. All these work phases are executed with the correct tools, as I said, and so we developed and produced in-house our own work trains that are especially produced for the fast slab track system. So you can see we have 3 types of trains. We have the track and ballast removal train, a slab laying train, and a concrete casting train. These enable us to work in an automated way with high quality. Obviously, also the construction site follows this scheme. So we have a construction site that is divided into sequential work zones that all work in a contemporary way, but in different areas. So the installation is organized in a zone where we have the ballast removal, one where the slabs are being laid, and one where we are casting our concrete. But let's also talk about numbers. So in the last years, we gained some experience in track work and in building our slab track. And our peak performance is for sure the track renewals. So we're talking here about dismantling ballasted track and building a new slab track in 7-hour track possession. So working by night, traveling by day, and it is possible to build up to 57 meters of a slab track in just 7 hours of track possession. Another kind of numbers, so this is what we did so far, starting July 2023. Right now we have over 32 kilometers of fast slab track system built in Italy, and this means that more than 6,800 slabs have been installed in both metro and railway networks. And this is an example of a typical work schedule. So focusing on a 7-hour track possession, which is, as I said, our peak performance, we can see that the work is organized this way. So we have some time that gets lost, obviously, to travel to the work site and to go back, but then every operation is happening almost at the same time. This is actually the case of a real scenario. We were working at a tunnel in Italy, the Galleria Carrito. This was a 3.5 meter long tunnel with a single track, and we were working just in night shifts, and every day the traffic had been resumed. How did it go? So, you can see, this is the tunnel when it was finished. During the day, obviously, we are doing some auxiliary work. We are loading the materials on the trains, the raw materials for the concrete, the slabs on the slab laying train, and organize the work for the night. The first thing we are doing is doing the excavation works. So, the train that is working first is the track and ballast removal train. We are working with sections. Track sections are separated and loaded on the train and then automatically piled on the wagons. The same thing happens then with the ballast. The ballast is taken and collected and then stored into hopper wagons. And then it is brought outside the working site and then it gets disposed of. In this phase, we are also controlling the underneath layer and, in case, putting the right material in place. Subsequently, in the same section where the ballasted track had been removed, we are proceeding with the laying of the new slabs. This means that the slab laying train is coming forward, the slabs are brought to the front of the train and lowered with a crane, put in place by the operators that are working with a rough alignment at first of the slabs, acting on the screws of the mechanical support system, and also with spindles that are pushing from the sides. All the slabs are equipped with short rails. These short rails are then joined together mechanically with fish plates and bolts. And the last plate is then obviously linked with the existing ballasted track that is in front, and that will be worked the day after. So this way we are substituting, as I said, almost 60 meters of track. Behind this construction area, we are going forward with our work. So we are substituting the short rails with long new rails, normally with 108-meter rails. Checking the geometry. This time the quality of the alignment needs to be perfect. And this is actually the operation that needs more time to be executed. We are installing then the molds that are containing the concrete casting. And finally, our concrete casting train is coming to the working site. All the materials are already on the wagons on the back. So as you can see, we have the aggregates, we have cements, filler, water, and in the front there is the mixer for the production of the concrete. It is a real production unit, so we can perfectly register every batch that we are producing. And the concrete is directly poured inside the stoppers until the whole slab is filled. Once it is completed, we can remove the molds. And before the resumption of traffic, we are controlling the geometry of the track. We have, for this, extra instruments that are installed on our trains. And once the work is done, the trains go back, leave the construction site, and the morning after, the trains are running. And here you see not just the rendering, but also a real train running over our slab track. The productivities, you have seen them before. I have stressed you a bit with this number, so it's up to 57 meters per night shift. So summarizing, what are the advantages of our system and what is new about our system? So we are able to substitute ballasted track with slab track using night possessions. We have high productivity, up to 57 meters. We can daily resume train operations. Rail seats can be positioned with high precision, so we can manage tight curves, transition curves up to 150 meters, and gain optimal alignment of our track. Obviously, also the replacement of individual slabs is possible. So what can I say? FAST is not just the slab, but actually a complete slab track solution. Thank you.
Thank you very much.
And I finished also in advance.
Perfect. Thank you very much, Ms. Besemer, for your very interesting presentation on the Salcef Group's proven expertise on substituting a ballasted track in a 7-hour shift. Quite interesting. Thank you for your presentation. And let's hand over to our third presentation today in the morning. I would like to introduce to you and say hello to Tatjana Simić. She's the Managing Director of TAK&TRACK BEOGRAD in Serbia, and she will give us a presentation together with Professor Burcic, who is at the Civil Engineering Department in Belgrade also working. So you give us an interesting presentation on slab track as a response to the modern demand for sustainable rail system. So a very big field of application. So let's see what is behind. Thank you very much.
Good morning, everyone. I would like to extend a warm welcome to everyone, and I also want to offer my sincere congratulations on a job well done. First of all, I would like to introduce myself. I begin my professional journey as a designer at the Transport Institute CIFI in the department responsible for design on railway stations and infrastructure. Later, I continued work on so many projects through the COVI branch office in Belgrade, and today through my own company, TAK&TRACK in Belgrade. Over time, my curiosity and drive to learn led me to expand into designing both superstructure and substructure railway systems. I have had the privilege of participating in the modernization of railways network in abroad, in Serbia and the region. Also, my knowledge was extended with urban transport infrastructure like tram system and now on the metro project. This experience led me to today's topic, the slab track system prepared together with Professor Stanko Brčić. The presentation is organized with 7 key bullet points. Each one represents a section highlighted in the paper and will guide my presentation today. In recent years, maintenance costs have risen and track geometry decays more quickly. This has prompted the search for innovative solutions, especially for high traffic section and for high-speed rail. One such solution is slab track, which replaced traditional ballast. This modern superstructure design offers significant advantages. It provides greater stability, reduces the need for regular maintenance, and extends its lifespan. Slab track minimizes deformations and ensures superior track geometry, leading to improved safety, passenger comfort, and lower operational costs. The choice of the track type depends on several factors. It is based on the assumed layers of the superstructure, which form the model and are used for calculation. Slab tracks can be classified by how rails are fastened, by the stiffness of the system, And the last but not the least, environmental aspect. Let's look at the element that influence track types selection. Fastening system, including elastic, vibration reducing, or embedded fasteners. System rigidity, which can be finely tuned, use fastening materials and elastic layers. And finally, floating slab track, where the choice of materials, rubber, pneumatic cushions, or steel springs affects system behavior. The paper outlines performance characteristics based on installed elements and applied technologies, especially welding, and also it is in paper address transition from slab track to ballast track and drainage system in station and depots. There are technical specific that require careful attention. Currently, the Makish depot for line 1 on the Belgrade metro is under design, and these issues are being addressed. When we discuss about evaluating make decision process, consent process to use slab track, the simplest method is to assess its performance. This slide highlights the most important characteristic, the guide for decision-making process. As many of you know, the high speed of railway from Belgrade to Subotica is now in the last phase operational. A key structure on this route is the Čortanovci tunnel, consists of two separate tunnel tubes where the red track system used. A representative subject of demonstrating of the use the slab track of the Belgrade-Subotica railway line is the Beograd Center station and the Novi Beograd station, where the superstructure is constructed using slab track technology. Both were built with the slab track, showing how this technology is used in modern urban railway section. The Belgrade Metro project includes 3 lines and associates several depots. Currently, project documentation is being prepared and phased construction of line 1 at the Makish depot has started. Different types of slab track will be used depending on the purpose and location of each section inside or outside the facilities. You can see on the left side the alignment for the 3 metro lines, and the second picture, the construction depends on the location of this part. Generation of the noise and vibration is a rather important environmental issue related to railway and or tramway lines in big cities or populated areas. Both noise and vibrations are a natural consequence of rail vehicle motion. The main source of noise and vibration is related to wheel-rail contact. Acoustic waves represent noise, while the stress waves represent vibrations. Acoustic waves or noise spread through the air, while the stress waves or vibrations spread through the solid media, rail track structures, formation, and ground. The general problem and effect of noise and vibration is manifested through the interaction of the 3 connected elements: source of noise and vibrations, medium through which noise and vibration spread, object which is exposed to noise and vibrations, receiver. The reduced noise and vibration we can act on 3 levels: measures at the source, measures along the path, measures upon the affected structure. Noise and vibrations generated due to rail vehicle motion are interconnected. Suppression of the suppresses the other to some extent. The most effective protection from noise and vibrations is at the source, elastic fastening rails or patents as a vanguard system, elastomeric layers of various forms below sleepers, or reinforced concrete track slabs. In addition, effective measures to suppress noise are achieved by various acoustic barriers along the track. The suppressed traffic induced vibration upon important vibration-sensitive facilities. Special vibration isolation systems may be applied to building in question. Slab track structure have proven their value in practice. There is still room for improvement and integration with other infrastructure elements, such as signaling system, power supply, and the civil engineering components. Interface with other technical disciplines remain open for discussion and further development. Finally, here you can see a short video from my private archive, a test run recorded in 2022, in which I had the opportunity to personally take part. The video shows the first completed section of the Belgrade-Novi Sad railway line before and after the Čortanovci tunnel, including the viaduct at the transition zone between the slab and the ballast track, a clear example of slab track in real operation. Slab track connecting technology, sustainability, and progress. Our work today builds the foundation for the railways of tomorrow. I believe cooperation and innovation will lead forward to a safer, faster, and greener railway future. Every new project reminds us that behind every rail and every design stand human effort, knowledge, and passion for progress. And gathering like this forum truly inspires us, giving the chance to share experience, exchange ideas, and make our collective knowledge even stronger. And thank you very much for your attention. It was a pleasure presenting in the Railway Forum.
So thank you very much, Ms. Simić. You gave us a very good overview on the advantages of slab track systems compared to ballasted tracks, and also the opportunity to reduce noise and vibrations. There are certain solutions you have presented to us. Very good. So we are good in time. So I would now give the floor to you. We have the first three presentations fixed now, and if there are any questions you want to ask to the speakers, please feel free. The lady over there has a microphone, so if you would raise your hands, shortly say your name, where do you come from, and then raise the question, and then we will hand it over to the presenters to give the appropriate answer to it. Yes, please.
Salve, buongiorno, Modestino Ferrari, CIFI di Napoli. Innanzitutto complimenti.
It's Ferrari, President Chief in Naples. Many thanks and congratulations to all of you. I would like to ask one question to the EURAIL representative, especially when Spock is talking about the temporary screws for the laying of actually the slabs and the track, and also the use of the very same system for the replacement in case of maintenance or breakage of the slab. How do you act or how do you intervene? Because actually for the final organization of the slab, you have the grouting at the end. So how do you act in the meanwhile as a temporary solution? Thank you.
Grazie per la domanda molto.
Many thanks for this highly interesting question. I answer in English so the others can understand me as well.
So for those who are not Italian speakers, Mr. Ferraro was asking me how is it possible to do the maintenance work, so the substitution of the slabs once they're cast in if they get damaged. And so actually, thank you for your question. I was saying that we can reintroduce the screws inside the slabs to detach it. It's actually not so simple. So the slabs are made with a counter slope in order to be really fixed inside the concrete pouring. Also, our stopper has a conical shape. So we actually need to go and cut the concrete in order to free our slab. And then by acting on the screws, we can detach the slab directly from the underneath layer because we also have a separation mat. So I did not mention it by words, but it was in the video. So on the underside of the slab, we have the separation mat that also helps the detachment. And so this way we can elevate the slab, remove it, and then replace it.
Many thanks. Thank you.
Stefan von Boon, Rombeck Sursa. I have a follow-up question to that. How do you then install the new one? Because the in-situ concrete is still there.
So, thank you, Stefan. When we are detaching the slab, then we are doing, we're taking away a small part of the concrete, and then by using other types of materials, that are working on very thin thicknesses, we are able to put there the new slab and then attach it to the rest. But I don't know if maybe my colleague here can give a better answer than me. No? Okay.
Thank you very much. Any other questions to the speakers?
Again, me, Stefan von Boon, Rombeck Sursa. I have a question for Vlad Metaxa and Rudi Felsner. I don't know where they're sitting. Over there. You mentioned that you don't need any shear keys or any connector between the asphalt and the SCC. I saw a video on LinkedIn where it looked like you are milling a certain roughness into the asphalt top layer. Did I see something wrong, or is this what you're actually doing? Or can you clarify how the connection between the SCC and the asphalt is actually working that well?
Yes, so from, as you correctly see, there is a milling of the top surface of the asphalt to open up the aggregates, and that secures, having that roughness secures a good bonding between the self-compacting concrete and the asphalt. Yeah. So I don't know from structural point of view if there is anything to be said about it. Yeah. I hope that answers the question. Thank you.
Thank you. Anyone else? Then I would like to give a question also to the colleagues from the PORR company. As we have heard also from the question from the colleague before, obviously derailments are a certain risk also on slab track systems. So the question is, I think we are facing in Austria already 2 derailments on slab track systems. How can you ensure a very quick renewal of broken slabs or whatever happened? Could you give us a short overview how it is done with the PORR system?
Yeah, so that's a very good question, and I think, we have to face it. It happens. Yeah, it's not related to track, The events I think that you are talking about were related to rolling stock, failure of the rolling stock, but dragging the rolling stock over the slab track. And it is our approach in this, to respond to this challenge, our way of doing it is during the maintenance and operation manuals creation, our first step is to give the authority the possibility to evaluate the structural status of the slab, affected slabs. We don't necessarily want to change it right away. Yeah, so that will be the ultimate thing to do. What we want to look at first is if can be reused and just repaired on position. If that is okay, then we can remove the fastening system, we can remove the rail eventually if it's needed, and then recast the support point without changing the slab. However, in a case if that's not possible and the slab is structurally damaged and the failure is there, then we will need to replace. And in that case, the whole process that was more or less described also with the overrail system, it's similar. And the only maybe difference is that we need just to break the mid side of the slab, and then we will remove it and replace it. I hope that addresses the question.
Thank you very much.
Thank you.
We are very good in time, 15 minutes ahead of schedule. That's unusual for railway engineers, but I'm very happy about it. So if there are no more questions, I think we can go to our first coffee break. But before, I would like to give you some short information too. All of you who participate in this two-day meeting today can receive all the papers from the presenters on the homepage or on the website of the UEEIV within the next days. So you will have the possibility to get all the papers. And the second thing I wanted to give you on your way to the coffee shop, please visit also our booths. A lot of companies demonstrate their presence here in the seminar also with booths. So please feel free to go there, have a look at it, what they present there, and then take a coffee. I think we are so good in time, we could probably extend the coffee break, I think for a few minutes. So it's now 1100. I think if we start now, if you are back in, let's say, half an hour, 11:30, I would be happy that we start a little bit earlier, that we have a little bit time in the afterwards if we run a little bit late. So thank you very much and have a good coffee break.